Welcome back, friends. In this video, we're going to do two application examples where we talk about solving a right triangle. In this first example, imagine that you are standing 40 feet from the base of a tree. And we know that the angle of elevation from the ground to the top of the tree is approximately 70 degrees. We need to determine what the estimated height of the tree is. All right, so there is a key word in here that I want to make sure you guys are paying attention to, but we've got this new angle of elevation. All right, so I want to define what the angle of elevation and the angle of depression are before we start this problem and then the next problem. So if we have a horizontal line, if this is my horizontal, then the angle of elevation is going to be up off of that horizontal. So there's my angle of elevation. That means we are moving up off of the horizontal we're considering. In this situation, we're going to be moving up from the ground. Furthermore, we could also have, say, some angle of depression. And the angle of depression moves down from the horizontal. All right, so angle of elevation will move up from whatever your horizontal line of sight is, from the ground, whatever it says, from the top of a cliff. You just have to read the problem. Elevation moves up off of that imaginary horizontal line, whereas angle of depression moves down. And in the next example, we have both an angle of elevation and depression. All right, so let's focus on decoding this problem. So the most helpful thing we're doing when we try to set these up is going to be to draw a picture. So here's my ground, and here's me. This is where I'm standing. We'll call that point A. And we have a tree off in the distance that we're looking at. I'm going to draw a beautiful tree, light, fluffy leaves. So we have a tree. And what we want to know is the height of the tree. So we're interested in this vertical height here. So I'm going to call the top of the tree T, and I'm going to call the base of the tree B. These are all variables. They all, mean whatever I want them to mean, and I can use whatever letters I want as long as I know what the intended meaning of them is. So A is where I'm standing, B is the base of the tree, T is the top of the tree. All right, so I do know the distance between A and B. I'm standing 40 feet from the base of the tree. So we know the distance between A and B is 40 feet. I also know the angle of elevation. That angle of elevation from the ground to the top of the tree is 70 degrees. So where am I going to draw my little curve for the angle arc? And that's going to be rising up off the horizontal. So from the ground up, that creates my angle of elevation, which points to the top of the tree. So this angle measure right here is 70 degrees. So I've drawn my picture. I know two angle measures because I know right down here I've got my base. So I've got two angles and a length. So if I know three pieces, I can find any of the other three pieces. In this problem, we're being asked to determine what is the height of the tree. And the height of the tree is this height from T to B. So I need to determine that height. So I'm going to redraw my triangle without all of the fun pieces. Let's say we've got 70 degrees I have angle A, angle B is my right angle, and I've got my top of the tree T. I also know the distance from A to B is 40. If I were to label this side from A to B, what angle is it opposite? It's opposite capital T, so I would call this little t. Furthermore, I'm interested in the height. I'm interested in the side which is opposite 70 degrees, which we call angle A. So we'll call that little a. Remember, we always use capital letters for our angle vertices, and then the side opposite them, we're going to use the corresponding lowercase letter. So I want to find little a. What do I know in relation to angle 70? So I know the adjacent side, and I want to determine the opposite side. Opposite and adjacent, opposite and adjacent. Going back to my SOHCAHTOA, opposite and adjacent lets me know I'm going to choose tangent. So the way I would set this up is I would say tangent of my acute angle 70 degrees is going to be the opposite side over the adjacent side. Little a is opposite and 40 is adjacent. So this is the equation I need to use to solve. And very easily, since this is a divided by 40, I can use the inverse operation. I'll multiply by 40. I have 40 tangent 70 degrees equals a. So at this point, we type that straight into our calculator, making sure that we're in degree mode. And I have that a is 109.899097, or rather a is 109.9, and my unit, since the base between A and B was measured in feet, the height is measured in feet. So the tree is roughly 110 feet tall. And of course, you always want to round on any homework, quiz, or test problem. It's always going to be specified. And if I've given you something and that is not specified, you just want to make sure that you round to the 2 decimal places, I would say is generally pretty good. But anything you're doing in My Math Lab, it's going to say round to the whole number, tenths place, 2 decimal places, 100ths place, etc. All right, let's look at one more example while we're in this video and we're dealing with angles of elevation and angles of depression. For our next example in this video, we have a window washer on a ladder looking at a nearby building, and he was able to measure that he is 100 feet away from the building. He can measure the angle of elevation to the top of the building, so that angle of elevation is 18.7, and that the angle of depression going down to the bottom of the building, is 6.5. So what we have to say is, how tall is the nearby building? That needs a question mark. So let's draw a picture. Here we have our ground, and the window washer is up in the air on a ladder. I'm going to use a W for him. And there's a building on the other side that he's looking at. So this guy's my building here. What we want to know is the height of this building. Well, what were we given? So we have this imaginary horizontal where the window washer is looking straight out. One thing we know is that he measures the angle of elevation to the top to be 18.7. So that means going to the top of this building, we know the angle off that horizontal, I'll say theta, is 18.7 degrees. He can also measure this angle of depression to the base of the building. So that angle down from the horizontal, I'll call that alpha, is 6.5 degrees. The other piece of information we know is we know the length from the window washer to this building. We know the distance, this horizontal distance at the bottom, is 100 feet. So we need to determine the total height of the building. Well, what I want you to see is we have two right triangles here. I have one for the angle of elevation as well as this one below for my angle of depression. So I know an angle and a length and then a right angle for each of these. What I want to find is height 1 and height 2, because if I know those two heights, those two vertical sides on each of those right triangles, I can add them together and that will give me my total height. So I have two small right triangles to solve. I'm going to draw them each over here on the side. They may not be to scale, but I've got my angle, 18.7. I know this is 100, and there's my H1, as well as this triangle here with an angle 6.5, again a measure of 100, and height 2. So I'm going to erase my first drawing so I have more space on my screen. So for my red right triangle, I have an adjacent side, and again, I'm looking for an opposite side. Opposite and adjacent lets me know I'm going to use tangent. So I can say that tangent of 18.7 equals opposite over adjacent, h sub 1 over 100. Or rather, h sub 1 equals 100 tangent 18.7. So this number is exact right now. When I type it into my calculator, I'm going to get an approximate decimal. So I'm going to wait and add this exact number to the exact number I get from this second calculation, and I'll do that in my calculator all in one step. So again, we look at this triangle. We have 6.5. 100 is adjacent to the angle we are considering, and H2 is opposite. So this triangle also uses tangent. All three triangles we've solved in this video used tangent. That's just a coincidence. But I've got tangent of 6.5 equals opposite over adjacent. So h sub 2 over 100. H sub 2 is 100 times tangent 6.5. So I know the sum of h sub 1 plus h sub 2, that's going to give me the total height of my building. So I would go to my calculator and I would type this in. I would say 100 tangent, your calculator is going to open a parenthesis there. So 100 tangent 18.7 plus 100 tangent 6.5. Technically, you don't need these associative parentheses. I'm just using them for grouping purposes. And as long as you are doing this in degree mode, your output is going to be 45.24169341, or rather just 45.2 feet tall. So I know I erased part of that picture to keep my screen from getting too crowded, but you can always rewind in the video and go back and compare if you have any questions. So I hope that helps you with some application problems. I've got one more video I'm going to do in this series.